Good morning. Happy Tuesday. The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmail@ybcc.edu and I'll respond as soon as I can. So today we're going to go on and cover section 6.7. But before we do that, do any of you have any questions from 6.6 that you want to look at this point in time? I will take that as a no. Okay. So 6.7, here we go. We have gone over how to solve first degree equations by putting the variable on one side of the equation and a constant on the other side of the equation through various steps. We're going to start looking at how to solve equations of higher degree, second, third, fourth, fifth, etc. degree equations. And to do that, we're going to start with something called the zero factor property. The zero factor property. Basically, what that is, let's see, I guess there's a hyphen there. What that is, it says that if you have A times B equals 0, so you have a product equal to 0, then either A equals 0 or B equals 0 or both A and B equal 0. Now, this only works when it's set equal to 0. There isn't the 10 factor property or the -6 factor property. It's got to be a product set equal to 0. Then we can go back and say, well, any one of the given factors could equal 0 to make that true. We're going to use the factoring techniques we've been learning to deal with this situation. Let's start out with a problem. X plus 2 times x plus 3 equals 0. So on the left side of the equation, we have what was a trinomial that has been factored completely. But if it's set equal to 0, now it's in that form, A times B equals 0. So that means that either x plus 2 equals 0 or x plus 3 equals 0, or both of them are equal to 0. What we've done is we've taken a second degree equation and we've broken it down into two first degree equations. And we already know how to solve first degree equations. So for the equation on the left, subtract 2 from both sides, and we get x equals -2. For the equation on the right, subtract 3 from both sides, and we get x equals -3. Notice there are two solutions. Let's check our work. Well, if x is -2 and we put that right there, we get -2 plus 2 times -2 plus 3 equals 0. Well, -2 plus 2 is 0. I can stop right there because 0 times anything is 0. So that's going to work. Likewise, if I take x equals -3 and put it in there, and there we'll have -3 plus 2 times -3 plus 3 equals 0. And anything times 0 is going to equal 0. So that checks as well. So for this equation, we have two solutions, x equals -2 and x equals -3. Any questions on this example? Okay, let's take a look at another example. X minus 8 times x plus 8 equals 0. Once again, it's in that form of A times B equals 0. So that means x minus 8 equals 0 or x plus 8 equals 0. Well, if x minus 8 equals 0, adding 8 to both sides, x equals 8. If x plus 8 equals 0, subtracting 8 from both sides, x equals -8. So once again, we have two solutions to this equation. Again, any questions? All right, here's another example. 5x times the quantity 5x plus 7 equals 0. So that means either 5x equals 0 or 5x plus 7 equals 0 or both. If 5x equals 0, dividing both sides by 5, x equals 0. If 5x plus 7 equals 0, subtracting 7 from both sides, and then dividing both sides by 5, x equals negative 7/5. So again, we have two solutions to a second degree equation. Any questions? All right. Suppose we have the following. We have n times n plus 1 times n minus 6 equals 0. Well, now we have a third degree equation. So n equals 0, or n plus 1 equals 0, or n minus 6 equals 0. If n equals 0, well then n equals 0. If n plus 1 equals 0, subtracting 1 from both sides, we get n equals negative 1. And if n minus 6 equals 0, adding 6 to both sides of the equation, we get n equals 6. So we have three solutions to what is a third degree equation. Any questions about that problem? Okay, now suppose we have x squared plus 7x plus 6 equals 0. We still have something equal to 0, but the something is not factored into the form a times b or a times b times c or whatever. So what we need to do now is apply all these rules we've been learning about factoring to the left side of the equation. Well, it's a trinomial. It's in standard form. There's no greatest common factor. It's not a perfect square because 6 isn't a square. It does have a leading coefficient of a 1 though. So I'm looking for what? A product that's 6 and a sum that's 7, 6 and 1. So plus 6 plus 1 equals 0. Now, by factoring the left side of the equation, I have it in the form of a times b equals 0. So now it looks like the previous problems that we did. At this point, we take each factor that contains a variable and set it equal to 0. That's a 1, it looks like a 7. And solve each first degree equation. X plus 6 equals 0, subtract 6 from both sides, x equals negative 6. X plus 1 equals 0, subtract 1 from both sides, x equals negative 1. Let's take negative 6 and check our work. So we'll plug that back in here. Negative 6 squared plus 7 times negative 6 plus 6 equals 0. Negative 6 times negative 6 is positive 36. 7 times negative 6 is negative 42 plus 6. Well, 36 plus 6 is 42 minus 42 is 0. 0 equals 0. So that one checks. How about x equals negative 1? So plugging that in here, negative 1, the quantity squared, plus 7 times negative 1 plus 6 equals 0. Negative 1, the quantity squared is 1. 7 times negative 1 is negative 7. And we get 1 plus 6 is 7 plus negative 6, 0 equals 0. So both solutions check. This is a second degree equation. It has two solutions. Any questions so far? All right. What about this one? Let's see. Oops. X squared minus 14x plus 45 equals 0. Here we have a second degree equation. It's a second degree because the highest power of the variable is a 2, okay? And it's in standard form. That is, it's in the form ax squared plus bx plus c equals 0. Okay. On the left side of the equation, we have a trinomial. It's, let's see, it's in standard form. It doesn't have any greatest common factors, not a perfect square, but it has a leading coefficient of a 1. Let's see, the product is 45 and the sum is negative 14. How about negative 9 and negative 5? So that's how we get that. So now it's in the form a times b equals 0. So x minus 9 equals 0. X minus 5 equals 0. If x minus 9 equals 0, adding 9 to both sides, x equals 9. If x minus 5 equals 0, adding 5 to both sides, x equals 5. If x is 9, we get 9 squared minus 14 times 9 plus 45 equals 0. 81, let's see, that would be minus 90 and 36 minus 126 plus 45 equals 0. 126 minus 126, that one checks. If x is 5, 5 squared minus 14 times 5 plus 45 equals 0. 25 minus 70 plus 45, we get 0 equals 0. So again, this second degree equation has two solutions. Let's see here. How about this one? X squared minus 36 equals 0. Well, this is in standard form. So on the left side of the equation, though, what do we have? Oh, it's the difference of two squares. So we get x plus 6 times x minus 6 equals 0. So then x plus 6 equals 0, x minus 6 equals 0. If x plus 6 equals 0, subtracting 6 from both sides, we get x is negative 6. If x minus 6 is 0, adding 6 to both sides, we get x equals 6. So again, two solutions to a second degree equation. How about this one? 16z squared minus 25 equals 0. Here we have the difference of two squares set equal to 0. So 4z plus 5 times 4z minus 5 equals 0. That means that 4z plus 5 equals 0, or 4z minus 5 equals 0. Solving the first equation, the one on the left, subtracting 5 from both sides, and then dividing by 4. On the right, adding 5 to both sides, and then dividing by 4. So z equals negative 5/4 and z equals positive 5/4. Again, any questions? All right. How about this one? X squared equals 5x. Well, we have a problem here. This is not in standard form. It's a second degree equation, but it's not set equal to 0. So I'm going to subtract 5x from both sides of the equation. Now, a typical mistake at this point is people look at that and they say, well, it kind of looks like the difference of two squares. It's a binomial with a subtraction sign, and x squared is a square, but 5x isn't. And so they bail out and say, well, it's not factorable. There's no solution. But wait, before you consider the difference of two squares, you should always look for a greatest common factor, which is an x. So we've got it factored into two factors. So that means either x equals 0 or x minus 5 equals 0. Well, if x equals 0, then x equals 0. If x minus 5 equals 0, adding 5 to both sides of the equation, x equals 5. So second degree equation, two solutions. Okay. Again, everybody keeping up okay? I can slow down if we need to. Everybody's all right? Okay. 3x squared plus 14x equals -8. Well, again, this is a second degree equation. I know because of the 3x squared, but it's not in standard form. So I'm going to add 8 to both sides of the equation. So now it's in standard form, set equal to 0. On the left side of the equation, we have a trinomial. There's no greatest common factor. It's not a perfect square. It doesn't have a leading coefficient of a 1. So it looks to me like grouping or trial and check. I'm going to use grouping. Again, if anyone wants, I'll do it with trial and check as well. Okay, so A is 3, B is 14, C equals 8, the product is 24, and the sum is 14. How about 12 and 2? 12 times 2 is 24. 12 plus 2 is 14. So I'm going to take this trinomial on the left side of the equation and apply factoring by grouping. So I've got 3x squared plus 12x plus 2x plus 8 equals 0. I'm going to split it down the middle into two groups of 2. The greatest common factor of the first two terms is 3x. The leftovers are x plus 4. So for the second set, the leftovers are still x plus 4. And I'd have a plus 2 on the left side there. Continuing to factor, I get x plus 4 times 3x plus 2 equals 0. So there we have it in the form a times b equals 0. So x plus 4 equals 0, 3x plus 2 equals 0. If x plus 4 equals 0, subtracting 4 from both sides, we get x equals -4. If 3x plus 2 equals 0, subtracting 2, we get 3x equals -2. Divide by 3, x equals -2/3. So we have that situation. So if it's not in standard form, we need to put it in standard form and then factor it. Okay, let's see here. How about this one? 5m times the quantity 5m plus 8 equals -16. Well, before you start celebrating and going, oh, cool, the left side's already factored, there's a problem. The left side may be factored, but it's not set equal to 0. It's the 0 factor property, not the -16 factor property. So what we have to do now is we have to multiply this out, 25m squared plus 40m equals -16. Then we're going to add 16 to both sides of the equation. 25m squared plus 40m plus 16 equals 0. Now I can factor it, but having it factored when it's not set equal to 0 is worse than not having it factored at all, because you have to multiply it together, shove everything to one side of the equation equal to 0 on the other, and then factor the side that's not 0. Okay, so what have we got? We've got a trinomial. It's in standard form. There's no greatest common factor. Oh, but it starts with a square, 25m squared. It ends with a square, 16. There's a plus sign in front of it. Let's see if it factors as a perfect square. 5m, 5m, 4, 4, and we need a plus sign in the middle. That gets us plus 20m. Plus 20m is plus 40m. Bingo. So it is a perfect square trinomial. So it has two identical factors. So that means 5m plus 4 equals 0. And 5m plus 4 equals 0. Mr. Mayo, since they're going to be the same answer, do we have to solve them both? No. We'll subtract 4, and we get 5m equals negative 4. Divide by 5, m equals negative 4/5. And this is going to give you m equals negative 4/5 as well. It's what's called a repeated solution, okay? Or the book just says negative 4/5 repeated. So we have two identical solutions. That may not be anything significant now, but when we get down to the end of the quarter, chapter 10, I think it is, where we're start graphing second degree equations, then this will mean something. But we'll come back to that later. Anyway, two identical solutions. Okay, let's see here. X cubed minus 7x squared plus 10x equals 0. This is a third degree equation, so it's going to have three solutions. Let's find out what they are. Well, the left side of the equation is already in standard form, but there's a greatest common factor of an x. So we'll take that out. And then the trinomial that's left is not a perfect square, but it has a leading coefficient of a 1. I'm looking for a product that's 10 and a sum that's negative 7. So negative 5 and negative 2. So I've got three factors containing a variable. So x equals 0, x minus 5 equals 0, x minus 2 equals 0. Well, if x equals 0, then in fact, x equals 0. If x minus 5 equals 0, adding 5 to both sides of the equation, x equals 5. If x minus 2 equals 0, adding 2 to both sides of the equation, x equals 2. Third degree equation, three solutions. Now, a third degree equation has three solutions. They may not always be real, but in the case of, in this course, we will only deal with real solutions. So if it's a third degree equation, we will come up with three real solutions. Okay, let's see here. What about this one? 9y squared equals 64. Well, this is a second degree equation, but it's not in standard form. So let's subtract 64 from both sides of the equation. We get 9y squared minus 64 is 0. On the left side of the equation, I have a binomial. It looks to me like it's the difference of two squares, because you could take it and write it as what? 3y, the quantity squared, minus 8, the quantity squared. So the factors would be 3y plus 8 times 3y minus 8 equals 0. So now we'll take each factor that contains a variable and set it equal to 0 and solve it. 3y plus 8 equals 0. If we subtract 8 from both sides, 3y is negative 8. Divide by 3, y is negative 8/3. If 3y minus 8 equals 0, add 8 to both sides. 3y equals 8. Divide by 3, y equals 8/3. Second degree equation, two solutions. Okay, let's see here. How about this one? P times P times P plus 1 equals 6. Again, before you start celebrating, it's not factored set equal to 0. So we need to multiply this back together. Subtract 6. Now it's set equal to 0. We'll come back and factor this trinomial. P and P, let's see, the product is negative 6. The sum is positive 1. How about 3 and negative 2? So then p plus 3 equals 0, p minus 2 equals 0. Subtracting 3, we get p is negative 3. Adding 2, we get p equals 2. I haven't been checking my work for a long time. I need to go back and do that. Let's take negative 3 and plug it in here. We'd get negative 3 times negative 3 plus 1 equals 6. Negative 3 times negative 2 equals 6. 6 equals 6. That one checks. P equals 2. We'll get 2 times 2 plus 1 equals 6. 2 times 3 equals 6. 6 equals 6. And it checks as well. Let's see here. How about this one? X minus 1 times x squared plus 5x plus 6 equals 0. Well, this has been factored partially already, that x minus 1, but I believe we can factor the rest of it even further. It's a trinomial standard form, no greatest common factor, not a perfect square, has a leading coefficient of a 1. So we're looking for a product that's 6 and a sum that's 5. How about 3 and 2? Okay. So x minus 1 equals 0, x plus 3 equals 0, x plus 2 equals 0. If x minus 1 equals 0, add 1 to both sides, we get x equals 1. If x plus 3 equals 0, subtract 3 from both sides, x equals negative 3. And if x plus 2 equals 0, subtract 2 from both sides, x equals negative 2. Okay, let's see here. How about this one? X cubed plus 7x squared equals x squared minus 9x. Well, the first thing I'm going to do is put it in standard form. I can have the 0 on the left or the right. I just prefer to have the 0 on the right. So I'm going to subtract x squared from both sides, and I'm going to add 9x to both sides. On the left, I'll get x cubed plus 6x squared plus 9x, and on the right side, I'll get 0. So now I have it in standard form, descending powers equal to 0. Well, on the left side, I can take out an x as the greatest common factor. Then the trinomial that's left looks like it might be a perfect square, and it is. So x is 0, x plus 3 equals 0, x plus 3 equals 0, x equals 0, subtract 3, x equals negative 3, x equals negative 3. So your solutions are 0, and then negative 3 is repeated. Okay. How about this one? Negative 8x squared plus 3 minus 10x equals 0. So what we have there is, well, it's not in standard form. It's set equal to 0, but standard form would look like that, right? Okay. Well, the next thing I'm going to do is take out the greatest common factor, or in this case, take out a negative 1. And let's clean that up a little bit. Okay. So that trinomial, we're going to use grouping. So A is 8, B is 10, C is negative 3, the product is negative 24, and the sum is 10. So how about 12 and negative 2? So then I've got negative 1, 8x squared plus 12x minus 2x minus 3 equals 0. Okay, I'm going to use factoring by grouping. -1, greatest common factor of the first two terms, 4x. I have 2x plus 3, 2x plus 3, and a -1 outside. So I get -1 times 2x plus 3 times 4x minus 1 equals 0. Now, I've said this over and over again, but it maybe didn't really have any meaning until right now. And this is what I've been saying. Take each factor that contains a variable and set it equal to 0. Well, -1 does not equal 0. And -1 is not a factor with a variable in it. -1 equals -1. So what do we do with that -1? Well, in this context, we can ignore it. Why can we ignore it? Because if we wanted to, we could come in and divide both sides by -1. And basically, we wouldn't even have to deal with it at all. Okay, dividing both sides by -1, we'd still have these two factors equal 0. Because of that, instead, what we can do is just go back and take each factor, oops, that contains a variable and set it equal to 0. I don't have to do anything with the -1. -1 equals -1. So 2x plus 3 equals 0, subtract 3, 2x equals -3, divide by 2, x is -3 halves. 4x minus 1 equals 0, add 1 to both sides, 4x equals 1, divide by 4, x equals 1/4. Second degree equation, 2 solutions. How about this one? Q squared minus 1/4 equals 0. We looked at some problems at the end of class yesterday dealing with fractions. So this becomes what? Q plus 1/2 times Q minus 1/2 equals 0. Q squared minus 1/4 would be Q squared minus a half squared. A half times a half is a fourth. So Q plus 1/2 equals 0. Q minus 1/2 equals 0. Oops. We're going to subtract a half here. Q equals -1/2. We'll add a half there. Q equals +1/2. Now, one of the common mistakes that I see students make on a test is after we've gone through all of this, then they have a problem, let's say like this one. And instead of taking advantage of the fact that it's already in the form a times b equals 0, and just going through and saying, well, it's got to be that, and it's got to be that. So add 3, x is 3, subtract 5, x is -5. Instead, for whatever reason, they decide to multiply this all together. X squared plus 5x minus 3x minus 15 equals 0. X squared plus 2x minus 15 equals 0. And then they factor it and they get x minus 3, x plus 5. And they're going around in circles. Okay. Now, why is this inappropriate? Because this is already factored, set equal to 0. If you have a problem like we looked at earlier, like this, where it's factored but not set equal to 0, that's when you've got to multiply it all out and move the 6 over. Okay. So make sure you differentiate between those two ideas. Well, that's all I have for you today. So if you haven't been brushing up on your factoring, you want to do so. We'll be using it the rest of this chapter as well as chapter 7. Okay. That's all I've got for now. I will be back this afternoon at 1:15. I'll go ahead and stop the